Welcome to another unit in the ISM exercise set Business Mathematics. This time with a unit about matrices. Let's have a look at the exercise. Calculate if possible the following expressions by using the matrices given below. If any expression cannot be calculated, argue why it is not possible. Then we have here three different matrices, A, B and C. And we have to calculate four different expressions. So in the first part it's an inverse, in the other three it's just multiplication. So let's start with the first one. Here we have the matrix A and want to get the inverse. So meaning we take our matrix and on the right put a vertical line, and on the right of this vertical line we put the unit matrix. Then we have three steps which we want to achieve. First off, make the left hand matrix look like an upper right triangular matrix. Then get all the diagonal elements to be 1 and then erase all the elements in the upper right. So here, first off, to make this a bit easier, we multiply the first row with 5, second row with 6. So then in the first column we have 30 and 30. So in this case we can just subtract the first row from the second row and also divide the first row by 30 again. Meaning we get here as a result not only on the left an upper right triangular matrix, we also already have on the diagonal only ones. And this is pretty neat because then we only need to get rid of the 7, 6. And this we can do by subtracting from the first row 7, 6 times the second row. And of course, whatever we do on the left, we also do for the matrix on the right, as we've seen with the steps above as well. So here, this will turn out as giving us on the left the unit matrix and on the right a different matrix. And the matrix on the right, that's then the inverse we were looking for. So the idea always is start with the inverse on the right, transform the matrix so that on the left you have the inverse, whatever is left on the right, that's your inverse matrix. And the steps you can take are the different steps of the Gauss algorithm. So this then concludes the first of the four different exercises. So let's step to the second. With the second, we had two matrices, C and B. Here, if we use the fork scheme, meaning we put the left-hand matrix the lower left, the right-hand matrix in the upper right, looks as follows. And also what we need to recall, before we know whether we actually are able to multiply two matrices, we need to assure that the number of columns in the left matrix equals the number of rows in the right matrix. Here we have a 1 times 3 matrix times a 3 times 2 matrix, so this is fulfilled. This also can be seen here in the fork scheme. There are actually fitting mixes here. So when we want to calculate the first entry or the entry in the first row and first column, we take the first row from the matrix on the left. So the first matrix and the matrix on the left, that's always in reference to rows. And we take the first column from the upper matrix, so whatever is on the right, or here in the upper part of the fork scheme, is referred to via the columns. So here we're at row 1, column 1, so we take the first row left and the first column in the upper part. Then we just multiply all the elements, adding up the results. So here it goes 1 times 1 plus 5 times 0 plus minus 7 times 2. So we have 1 minus 14 giving us the minus 13. Then for the second entry we are in the first row second column. So we take the first row left, second column and upper part. We go 1 times 4 plus 5 times 1 plus minus 7 times minus 1. So we have 4 plus 5 plus 7, giving us 16. And this then is our result, the matrix minus 13 plus 16. Let's hear once again the result. This then concludes already the second part, and we can continue with the third exercise. With 3, we wanted to calculate A times B, B times A. Here as well we can use the fork scheme, and we know it's possible because here we're multiplying a 3 times 2 with a 2 times 2 matrix. So the number of columns in the left matrix coincides with the number of rows in the second matrix. And here we also see in a fork scheme there is a match for all the different columns and rows. So then we use the same mechanism as described before. So for the entry, first column, first row, we take the first column in the left, first row in the left, first column in the upper part, multiply the elements and add this up. So 1 times 6 plus 4 times 5, giving us 26. For the entry in the first row, second column, we take the first row of B and the second column of A. So it goes 1 times 7 plus 4 times 6. So 7 plus 24, giving us 31. Then we continue. First row, first column. So it's 0 times 6 plus 1 times 5, giving us 5. Second row, second column, we take the second row of B, second column of A. So it's 0 times 7 plus 1 times 6, giving us 6. And finally, the last row, that's third row, first column, 2 times 6 plus minus 1 times 5. So 12 minus 5, still 7. And third row, second column, that's 2 times 7 plus minus 1 times 6, giving us 8. This then concludes the third part of this exercise. Finally, we have the fourth part. Here we are asked to calculate C times A. However, here we have a problem, because the number of columns in C, we recall C was a 1 times 3 matrix, does not coincide with the number of row in A, which was a 2 times 2 matrix. So this is not possible because the two do not meet. And well, with this comment, we then conclude this exercise. And I hope you enjoyed listening. And if you want to see more of this type of exercises, feel free to visit the rest of this exercise set or take a look at the corresponding playlist. I say goodbye and see you next time.